Hello, welcome everyone to our presentation. In the next 30 minutes, we would like to share with you how we at Getting Data implement vendor-agnostic MLOps platforms, how we boost data scientists' everyday work, and how we combine best-of-breed cloud and open-source technologies to build such platforms. Few words about us. I'm Krzysztof Zarzycki, and I'm a co-founder and CTO of Getting Data. We, as a company, specialize in building analytics solutions, big data platforms, and machine learning platforms.
Hi, I'm Marek Wiewiórka. I'm a chief data architect with over 15 years of commercial experience in delivering of analytical solutions, data warehousing, and big data solutions. I've recently earned Google Machine Learning Engineering certification. Apart from that, in my spare time, I'm finishing my PhD thesis in bioinformatics at Warsaw University of Technology.
A little introduction of our company. We help companies extract value from their data and build data-driven products. We live and breathe big data, cloud, and machine learning, inspired by working at the largest data shows like Spotify. We use a lot of open source to build our solutions, so we love to give back to the community. We do it by contributions to the projects that we use, by blogs or conferences like this one. Our clients are from many different industries, from digital natives, where many are from Sweden, like Truecaller, Spotify, or Acast, through banks like ING, or through telcos also, like Kcell, that was part of Telia, to e-commerce and many, many more. The harder the data problems they have, the more interesting they are to us. First, I hope to gain your trust that our presentation today compiles real-world experiences. At Getting Data, we were building big data systems like data lakes or analytics and data science platforms since 2015. Long before, we were building data dedicated ML platforms. Our first ML platform project started around 2018 when ING Bank approached us saying that they need our help in scaling out their machine learning efforts. This joint venture with many next iterations lasts till today. Throughout the next few years, we addressed similar needs of large telecoms like Play from Poland or Kcell from Kazakhstan. They were done on premises, but with a strong effort to make them cloud native. Last year, we started initiatives to introduce cloud-based MLOps platforms to our retail clients, to Truecaller, and in this year, we are building GCP-based MLOps platform for the largest Polish bank. Few other MLOps projects are very probable this year. Every time, in every case, we leverage the fact that we work in many different contexts and combine different requirements of our clients into one platform blueprint. Today, we would like to share with you some information about it. This is to start. This is not a sales pitch. We don't have a product to offer except our experience. Our experience is what we would like to share with you today. So as you are on this conference, you're probably at the company that already know that ML can boost its business. You also know that there is this new set of practices called MLOps. It is supposed to scale out ML efforts, right? Machine learning efforts. It should lower time to market, in the meantime, raising quality of the solutions and efficiency. But how to implement it? And for you, a data scientist, how your work can be boosted thanks to such MLOps platform? I start with main principles that lead us when creating our version of MLOps solution. First, the fundament of MLOps. We treat the ML models as it was software. We bake in the platform the CI/CD process that we know from software engineering. And like in software, the result of our work is the code. In data science, it is the source code of the pipeline that trains the model. not the model alone. This code must be versioned, properly tested, code reviewed, finally repeatably built to provide the artifacts, the model. Getting to the third point, our goal is to put data scientists behind the wheel. They should deliver the model from the idea to production and be able to maintain it there, so that IT is not a bottleneck in productization of ML, so that iteration of deployment to production was the shortest possible. Only data scientists know how often the model should be retrained, which version should be used or tested, what model metrics to look at, etc. So it is crucial that data scientists drive the whole definition of production deployment of the model. But we strive to give this power without limiting the freedom of the data scientist by putting him in some single stiff framework. What boosts their productivity is that they can use whatever tools they already know, or they can leverage also cutting edge tools that should bring the amazing results. Last but not least, from the deployment perspective, we believe that MLOps platform should be loosely coupled, modular. You are probably one leg or both legs in the cloud. So the platform we all wish for leverage the available cloud services in what they are best for. But on the other hand, it shouldn't lock us into the particular cloud vendor or to the functionalities that are missing or security requirements not met. These, the last ones, could eliminate the use in regulated corporations like banks. We should be able to swap the tools easily. We should be able to provide the missing functionalities ourselves. And in this way, we get to the last point. Thanks to loose coupling, we believe it should be possible to choose best of breed technologies instead of using all-in-one frameworks. Some products, either cloud services or open source, excel in orchestration, some in experiments tracking, and some in model serving. The landscape of technologies available in ML world is huge. It should be possible to combine any of them into one coherent platform. Let me quickly draw a logical architecture of the solution. In our vision, MLOps platform consists of three areas with dedicated functions. First, data scientists experiment and design a model in the so-called data science workbench. It's a laboratory that allows for free and isolated experimenting and machine learning pipeline design. The result of their work is the code of the machine learning pipeline, which is managed in the code repository. The pipeline code goes through the CI/CD process and builds Docker image out of it. We fire this image on the training platform and achieve a ready model stored in the model registry. Finally, we come to the deployment to production. Another CI/CD step forces the review of the results and engineering standards. Then it deploys the model on the serving infrastructure. From here, production applications can take advantage of it. Finally, there is detailed monitoring that allows extensive audit and technical monitoring of the model responses. But also, it can measure how the model affects business and production applications. This could allow you to, for example, run A/B tests of multiple model variants. Now, let's step into the data scientist's shoes and see what is his or her experience in the drawn areas.
Okay, in our vision of ML platform, the main focus is on usability and best user experience. This is why we put a lot of effort into preparing a unified and fully featured development environment for data scientists. The heart of it, at the same time, its main entry point is a customized and extended version of widely adopted Jupyter Lab web interface. We designed it with the following principles in mind. It must be fully containerized to be compatible with both Kubernetes, so deployed with Jupyter Hub Kube Spawner, as well with other Docker-based managed notebook services such as Google AI Platform notebooks. Jupyter Image Build System must be modularized so that some features, like, for example, specific cloud extensions or add-ons, can be easily turned on and off. It must adopt well-known from Python programming language batteries included approach when it comes to the organization of development environment. To put it short, it should contain local instances of all tools that are required for both data exploration and implementation of machine learning pipelines, including experiment metadata tracking and, of course, a scheduler. The concept of local and global instances will be covered in details when discussing ML model deployment development lifecycle. Since data science is a combination of data analytics and data engineering, the development environment must support both worlds. This is why we provide notebooks as well advanced code editor for comfortable programming in languages such as Python or SQL. It, of course, must provide an easy access to data by means of dedicated extensions. And last but not least, it must be composed of open source components so that further customizations are possible and can be potentially proposed back to the community. Okay, so let's now look under the hood and check what components are part of our data scientist integrated development environment and what challenges we face when customizing AI platform notebooks on Google Cloud. Most of the information shared here are applicable to any deployment, but some are specific to Google Managed Services. Okay, so in order to equip data scientists with all the tools that he or she may need, we extended the main Jupyter Lab launcher with the following tiles. A local instance of experiment tracking tool, for instance, MLflow, that is backed by SQLite database with the artifacts being stored on local file system instead of Google Cloud storage. Next, a local scheduler instance, in our case, Airflow, with support for sequential executor and Python virtual environments. Then a code server for the purpose of having Visual Studio Code editor in a browser. And finally, a nice add-on Kedro helper package for visualization of data pipelines, which is one of the Kedro plugins to make the data scientist's life easier and more comfortable. To achieve that, we additionally use two PyPy packages. The first one is Jupyter Server Proxy, and the other one is Jupyter Launcher Shortcuts. So the first one we used when we would like to start an instance of the third-party tool before accessing it, while the other one, so the Jupyter Launcher Shortcuts, which aims at providing a simple shortcuts to already running service. For instance, because we started the software together with the notebook, or it started manually as it requires providing some parameters. Extended version of GCS and BigQuery add-ons that help data scientists to work with Google services. BigQuery is extension especially useful since it is shipped with a nice SQL editor and metadata management tools. Finally, we created a Terraform module and used post-startup script option for AI platform notebooks customization. This shell script can be used for many purposes. In our case, we use it to tweak parameters of Google Inverting Proxy for better support of WebSockets required by code server. Okay, we mentioned Kedro, but wait a second, what actually Kedro is? You must remember Krzysztof saying that one of the principles we had in mind when designing MLOps platform was that it should reflect best-of-breed approach. We truly believe that companies that adopt the best-of-breed MLOps platform will be more able to adapt to technology shifts that we know are coming. Rather than being tied into a monolithic data science platform on a multi-year timescale, they will be able to adopt, use, and swap out products as their needs change. However, to achieve this level of freedom when it comes to selection of a tool for a specific purpose, for instance, for scheduling of our ML pipelines, we need to have a robust programming framework providing sufficient level of abstraction and modularization. This is high time we introduce Kedro, that in our opinion is a perfect solution for creating reproducible, maintainable, and modular data science code. It is written in Python and is distributed under Apache license. Kedro's main concept encompasses the following idea: project templating, also known as Kedro starters, separation of configuration and training code using environments, separation of data access and training code with data catalog abstraction, and finally, data pipelines abstraction. In the next few slides, I will present Kedro's main features that address most of the pain points that data scientists may come across when trying to productionalize their ML models. Okay, everything starts with the first line of code, right? Not really, unfortunately. Nowadays, even a very simple Hello World program requires to set up your development environment. So to prepare configuration files, add necessary dependencies, set runtime parameters, etc. This is just the beginning, since if you would like to follow the best DevOps practices, you need to set up CI/CD pipelines, code testing and linting, just to name a few. ML or data projects are not an exception here. They also require a lot of boilerplate code to make it fully operational. This is where Kedro, with its concept of starter, comes to help. Kedro Starter is, basically speaking, a cookie cutter-based template for ML projects that allow your collaborators to spend less time understanding how you set up your analytics project. And it can help you with the tasks such as standardizing project structure with clear separation between configuration, data, documentation, and code itself. Managing project dependencies with third-party integrations, for example, with Airflow, MLflow, Jupyter, or with seamless integration of PySpark, for example. Evangelizing your data scientists about clear code concept by providing them with working examples of well-structured code and unit testing setup. And finally, just getting started with Kedro easily. Last but not least, there are a few official Kedro starters developed by the community that you can find on the project's GitHub. For example, in order to bootstrap a project with PySpark support, you can just run the command from the bottom of the slide. Once done, you will be ready to customize them for your needs. Data catalog is yet another Kedro's concept that helps you to keep the data science code clean, maintainable, and reproducible. The basic idea is to fully separate the way you create inputs and outputs of your data transformations from your source code. To give you a better understanding, let's take a closer look at the example code. On the left side, you can see a typical way of working with your data sets using Pandas package. You must have seen this similar snippet thousands of times before and seems to be correct, right? Yes, it is. But imagine what happens in the following situations. You would like to prepare your code to use a different way of reading the data, for example, using PySpark instead of Pandas. You would like to prepare your code so that it can read only a subset of data extracted in a CSV format for quick development and testing on your laptop, and from BigQuery table when doing training on full data set in production environment. Or maybe you just would like to share the way you read a complex data source with your friend so that he or she can easily plug in his project. In each of these cases, you need to refactor your code each time you change something in the way you read or write your data, potentially in a number of places. This doesn't sound like optimal and elegant solution, right? Yes, and this is where data catalog comes into play. By means of it, you can define your data sources in a declarative way using YAML syntax and just reference them using aliases in your training pipelines. What is more, you can specify different backends for your data sources between environments while preserving the same alias so that it's transparent to your pipelines whether you are reading data from your CSV on your laptop or database table when running on production. The example on the right side of the slide presents how to achieve it using Kedro Data Catalog. Kedro comes with their support for most distributed storage systems like HDFS, S3, or GCS, as well as data sources like SQL databases, various file formats, or cloud-managed services. Okay, finally, let's get our hands dirty and write a training code that will crunch some data. It can be run locally or deployed at scale using schedulers like Apache Airflow or Kubeflow pipelines. In order to achieve separation between runtime environment and specific implementation, Kedro introduces a very lightweight abstraction of nodes and pipelines. Nodes are in fact just Python functions and can be combined into pipelines that are actually DAGs with optional inputs and outputs. Once you have your set of pipelines ready, you can execute them locally just by typing Kedro run. If you'd like to have such a nice interactive visualization of your processing code, like the one on the right side of the slide, you just need to install KedroVis plugin and launch it with KedroVis. Okay, armed with Kedro concepts and full-featured development environment, we are ready to start local development of data science pipelines. Your ideal MLflow workflow in our platform can be accomplished in the following steps. First, you of course need to log in into Jupyter Lab environment. That's pretty much easy. Then create a new project using a Kedro starter with all the necessary integrations like MLflow or Airflow so that you can run your ML pipeline end-to-end in your Jupyter Lab. Besides, a corresponding Python virtual environment and an IPython kernel with Kedro data catalog support will be created for you automatically. Then you need to simultaneously analyze your data with Jupyter notebooks and implement your pipelines using Visual Studio Code. When you're ready, you can run your code and check if artifacts and metrics are tracked in your local MLflow instance. Optionally, you can deploy your code with just one single command to your local Airflow instance and repeat until you are happy with your model and you are ready to go live. Okay, I assume you are ready, so let's go live then. Since Kubernetes as a deployment environment is de facto standard in MLOps world, our first task is to prepare a containerized version of our ML pipeline. You may be thinking that it's not that trivial task, but in fact, with Kedro Docker plugin, it is as simple as running 2 shell commands and you are done. Finally, you can generate schedule-specific DAGs that is to be deployed with Apache Airflow or Kubeflow pipelines using one of our plugins. Of course, all the above steps can be executed automatically by a CI/CD process once you've pushed your code to the project's Git repository. There are also some additional tasks that you may want to be included in your training pipeline. Some of them we have already implemented in the form of Kedro plugins, or we are currently working on doing so. Krzysztof will tell you more about our current Kedro-related efforts shortly. But just to name a few of them. So monitoring stability of your featured datasets with Kedro Popon, that is a Kedro plugin wrapping Popon Python package, which we developed together with ING and hope to open source shortly. Profiling resources required by specific tasks for optimal Kubernetes pod sizing. This is what we are currently working on. And finally, helping parameters tuning plugin. Again, it's our research topic at the moment. Okay, we have DAGs, containerized code. So we are ready for continuous training, right, Krzysztof?
Right. So after the ML pipeline is designed in the data science workbench, its code is in the repository, right? Here is the time for other pair of eyes to review the pipeline, like a data scientist or a manager. And after approval, the data scientist can relax and wait for training to start. CI/CD picks it up, validates it, and builds a container image that contains the whole training pipeline and all the dependencies, and can fire it on the data. Just instead of running it on one machine in a workbench, the pipeline can spread its wings on the entire scalable infrastructure provided by Kubernetes. Or in the context of a bank client, we also leveraged Anthos that provides us necessary security features and service mesh. The pipeline is a multi-step workflow that someone has to orchestrate. It can be Airflow under GCP Cloud Composer service. It can be also self-managed Airflow, which we had to do for the bank client because the managed service did not fulfill security requirements. It can be also open source, other open source project like Kubeflow, or its managed equivalent, GCP AI pipelines. We use these powerful services in more digital native environments, or where security requirements are not as stringent as in the bank. Once the pipeline has done its job, it produces 2 results: a detailed training trace, also known as an experiment, with many details of how it was carried out, and of course the model. To keep these traces or models, we use another open source component called MLflow. We found MLflow to be more powerful and better fulfill the needs of our clients than available managed cloud services. In MLflow, data scientists can explore experiments that were run and models that were built. He can compare the models in many ways and choose the one that seems the best for deployment to production. So finally, right, the chosen model needs to be served, right, in production to become useful. But how? How does the data scientist get their model deployed? He needs to meet again the gatekeeper, which is the CI/CD. In most of our deployments, it is based on GitLab and some of our components. This is where the data scientist defines the deployment definition. He does it through the code, of course, that is audited and needs to be reviewed by another pair of eyes. When the change is accepted, CI/CD takes the trained model from registry and deploys it to production. The same model can be served online and offline. For online, an HTTP service or gRPC service is created using another open source project called Seldon. It allows us to easily implement services for models created in various frameworks. Of course, it happens in the form of containers that run on Kubernetes. Seldon not only serves the model, but also gives us some extra functions, such as A/B testing, outlier detection, or very accurate monitoring. It is our current tool of choice for serving, but as almost every component in this platform, it is swappable. For an offline model application, the model can be made available to orchestrated batch processor. In the GCP world, that could be GCP Dataflow, but in AWS, it could be AWS Glue, for example. These produce scoring saved in data warehouse like BigQuery or Redshift, but elsewhere the key value store might be more appropriate. The last piece of the puzzle is model monitoring, crucial for data scientists to get feedback about their models. We give into hands of the data scientists thorough monitoring that collects both technical metrics as well as model quality measurements. It also collects all logs. It saves each request that got to the model and the response it gave back, correlated, of course. With this rich data, the data scientist can analyze model efficiency, optimize its performance, or investigate why it performs badly for some specific cases. An advanced monitoring function would be also to detect data drift or simply deterioration of the model quality. We can use that to fire up the model retraining on fresh data. Let me now dive in one detail after deployment to serving. So we have a model in registry. We have Seldon that can serve it, but how do we deliver this model from registry to Seldon? Usually there would be a need for an ML machine learning engineer that defines Seldon deployment, and that can be a pretty complex thing, especially when you would like to have A/B tests running, or also logging of the requests, monitoring, etc. But we said in the beginning, right, that data scientists should be self-serviced, so we don't want them to get stuck in these technical details. Plus, we said that there are some governance rules that require every change of the deployment to be tracked and reviewed for auditing purposes by other data scientists. But how these data scientists must review these complex Kubernetes deployments? So we solved this problem by introducing a tool we call Model Deployer. It abstracts out the complexity of the definition of Seldon deployment so that data scientists can easily operate on just model names and their versions and provide their configurations for a simple YAM definition stored in a Git repository. CI/CD on that Git repo runs model deployer that ensures that the deployed state on Seldon is exactly like defined in the configuration. It also reflects the change in model registry, like in MLflow, marking what the model is currently deployed in production and in what version. It also has other interesting features. It gives the possibility to define A/B tests. We plan to support random assignments, sticky hash-based assignment, or by providing the assignment externally. It can also do a dry run to see what changes will be applied. And of course, it supports currently Seldon, but we foresee supporting other deployment frameworks in future versions. The tool is currently not open source, but if you find the tool interesting and useful, we would consider this option. So to sum up, we find our perfect MLOps platform built from multiple best-of-breed components. These can be managed services on cloud or open source projects. Plus, we bet on modularity of the design so that platform can be fitted to specific needs of our clients or projects. But to make these components work coherently and provide data scientists the seamless experience, we needed to make few things. We provided pre-baked images and Jupyter plugins, right, to give batteries included experience. We leverage Kedro that allows us to abstract out the chosen technologies, plus to streamline and boost the data scientist work. We developed plugins like Kedro Airflow, Kedro Kubeflow to integrate with particular schedulers in training. But we can go further, right? We can support Argo, Prefect, or cloud-specific training services. And we introduced model deployer that abstracts out sophisticated deployments, where we deploy and how. And last but not least, we prepare the system to be deployed on multiple cloud vendors, leveraging their services. And also we actually deployed it on premise using Kubeflow in few client contexts. We are proud that we achieved such modularity. But while we are already achieved a lot, we are in a long journey. We built an R&D group that focuses on MLOps, pushing it forward further. Our ambition is to be the partner to go with when implementing your complete MLOps strategy. One of the main subjects that we research now is feature store. We have implemented before already feature store-like concepts, but now we'd like to build fully integrated experience for the data scientists of using the feature store. Leverage existing technologies like open source projects, Feast is in particular, or Google Feature Store that is coming soon, or use other clouds offering like AWS Feature Store. But that's not all. We would like to integrate Kedro, the data scientist environment, with the feature store and company-wide data discovery tools so that the data scientist can easily search through what data the company has in either feature or data stores and pull it into their projects. To cover the model deployment end-to-end, we must address configuration of serving in Kedro as well. Imagine that data scientists provide just a simple prediction function in the project, and the platform knows how to deploy it as a service or a batch job. Other than that, we plan to further work on advanced deployments, on retraining capabilities driven by data or model drifts, and finally put business outcome monitoring, attribution monitoring, so that we know how model answers influence the business applications and therefore can measure its true business relevant performance. But if you are not there yet with the MLOps maturity and you would like us to ask us how should you start, we would summarize it with such a sentence. Focus on unlocking your data scientists and their potential. I believe that this can be achieved with few steps. First, start with data science workbench. Scalable, isolated place where data scientist teams can freely build up their models in a streamlined fashion. Then put CI/CD as the gatekeeper. Models would be much more trusted by the whole company when they are built separately rather than delivered on, let's say, pen drive. Then finally build scalable training where more models and bigger ones can be built. This presentation is unfortunately too short to show a demo of what we built, but if you would like to see such a demo, reach out to us. We have something for you. Thank you for your attention. Dziękujemy za uwagę.